This Week in Radio Tech, episode 149, is brought to you by Axia and the range of studio accessories, intercoms, and sophisticated control and routing software that's all part of the Axia family. Visit Axia on the web at axiaaudio.com.
And now, our feature presentation.
Twert.
Your GPS receiver is easily wrong by 30 feet or more. Differential GPS is here to fix it. We'll tell you how in the next hour.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Doc?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land.
This is Kirk Harnack.
Chris Tarr joins me to chat with Gary Galbraith of Nautel. Gary tells us about aircraft NDB systems and differential GPS.
You're dialed in to This Week in Radio Tech.
It's time for This Week in Radio Tech. Hey, I'm Kirk Harnack. I am glad you're here. We've got a really exciting show. I'm delighted to finally get to bring you the subject matter and the pictures and the explanations that we're going to bring you today. This show, Twert, This Week in Radio Tech, is about radio technology, about audio, and about RF and transmitting and receiving, and maybe even high fidelity audio, sometimes really low fidelity audio. We try to cover it all here, and we invite your participation in the chat room. If you're watching live or listening live on the GFQ network, you can participate in the chat room very, very easily. You can watch the show live every Thursday at 8 p.m. Eastern Time, and the website is gfqlive.tv. gfqlive.tv. So if you're listening to the recorded version of my voice right now, you should try to make an appointment with yourself and your computer or your iPad or other device on a Thursday evening at 8 p.m. Eastern Time. And go to gfqlive.tv. Also want to make sure that we mention that the Twert Show has a Twitter feed. We try to remind you that the show is going to start and who the guest is going to be and what we're talking about. And that's simply at Twert Show, TWIRTSHOW, at Twert Show on Twitter. There's also a Facebook page for the Twert Show. I think you can just look up Twert Show on Facebook and you'll find it. Hey, we've got one of our usual co-hosts is with us. He's here to help harass our guest. And the co-host is Mr. Chris Tarr from Muckwonago, Wisconsin. Hey, Chris, how are you?
I'm doing all right, Kirk. Thanks for having me. I've been a busy. It's my day off, and I spent the entire day working. So what do you know?
Gee. Sometimes those are the busiest days. You work up, you compile a whole list of stuff to do on your day off.
You know, it was fun stuff. It was stuff that I like to do. It's like this past weekend, I went down to an AM station down near Chicago, did some tweaking on the ATU at the tower, and that was actually fun. I was looking forward to it. I was all excited to spend part of my my Sunday playing with the tower. It's the stuff I get to do. So it wasn't all bad. And what the heck? I'll have tomorrow to rest.
Did you do any geocaching?
I did not. The weather here, as I'm sure you've heard, is pretty crummy. So there has been no geocaching. There's fortunately we haven't gotten a lot of snow here, but in Madison, just an hour away, they've got about 14 inches. So a lot of blowing winds and rain and all kinds of yucky stuff outside. So I tried to stay in the house as much as I could today.
I know just enough about geocaching to imagine that if there's 14 inches of snow on the ground, ain't the best day to be geocaching.
It depends. Now, speaking of that, though, the group that I work for, Radio Milwaukee, nonprofit public media radio station in Milwaukee, we are looks like we're going to be moving into a new facility in downtown Milwaukee. And the first thing I was looking at, and I'm continuing to research, is where I'm going to hide the geocache around the building. Before anything else, before I run the path studies for the microwave link, anything, where's the geocache going to go?
Yeah, well, we're scoping out a new site for our studio. We want to make sure there's an appropriate number of places to hide geocaches.
I was just going to say, I have to go to the executive director and go, I'm sorry, we can't move there. It's, the microwave shot's okay, but there's no place to put a geocache, so we're going to have to find somewhere else.
Oh, geez. Oh, well. Chris, I love talking to you. Glad you're here, and glad you've got this new project of moving this radio station. It's good. I know you'll carry us through the process, but I want to hear about this as things go along.
Oh, there'll be some fun stories, I'm sure.
I'm guessing there'll be a few Thursdays when you're not here with us because you are pulling your hair out or lifting furniture or something.
Well, hopefully I'll get the internet connection in there early on so that I can share it with you guys.
Oh, and you can show us everybody else working while you do the show.
Yeah, I will supervise. Yes.
Well, hey, we have a guest on the show, and every other show or so we try to have a guest, and no exception here. Our guest on this show is Gary Galbraith from the company called Nautel. Now, if you've watched, well, first of all, let's welcome Gary. And hey, Gary, how are you?
Hey, hi, Kirk. How are you doing?
I'm really good. Thanks for asking. And speaking of snow, up there in Halifax, Nova Scotia, you guys get a lot of snow there?
We've had a little bit this year, but I don't know if it's going to stay. We're hoping to have a white Christmas, but who knows?
I know we talk about geocaching from time to time on the show. Do you ever do that? You ever go geocaching?
No, never done that. Never tried it.
Chris Tarr is like the grand poobah of geocaching. I've found a couple things here. You know what? I'd like to have a geocaching thing that could help me find my keys.
Oh, it's funny we're talking about this, Kirk. I actually have one of my geocaching shirts on right now.
Oh, Team Tar.
There you go.
Wow.
There you go.
That's serious business.
That's right.
So geocachers find things, and Gary Galbraith, he works for a company, Nautel, which I think started out by the name Nautel isn't that for nautical electronics?
Yes, yeah. The company name was originally Nautical Electronic Laboratories. So it when we moved into the AM and FM broadcast sphere, we kind of shortened that a bit to Nautel, just so it wouldn't be quite so much of a mouthful.
Well, Nautel is a good name. And I've been familiar with Nautel broadcast transmitters for quite some time. And by the way, a couple of your colleagues have been on the show. Chuck Kelly, Hal Neller was also on the show. So Chuck may have been on twice so far, just explaining about different concepts of broadcasting and transmission and making modulation and such. One thing that listeners and viewers of this show may not be so familiar with, though, is this whole idea of aids to navigation. Now, if you're a pilot, and I took pilot training, 20 some years ago, and I still have my license, of course, but we would learn about all these different aids to navigation that are used in aviation. And I never really thought about it until LORAN came to my attention, but there are also aids to navigation for ships in the maritime industry. So, Gary, can you take just a few minutes and kind of just tell us about this area of not broadcasting, but of providing, RF signals and beacons and just how these things are used? What are these aids to navigation?
Sure. Well, Nautel started out in 1969, and our very first product was non-directional radio beacons for airports. And that was something we developed for Transport Canada. And in fact, we developed the world's first solid-state non-directional radio beacon. And we've kind of moved on from there, from radio beacons into AM/FM, but also from our radio beacon line, we've moved that into DGPS transmission, which we'll talk about in a bit more detail soon, and also Navtex transmitters for shore-to-ship transmission of weather information and hazard information.
Tell me, what is a radio buoy, or something that is out at sea? What does that look like?
Well, the transmitters that we manufacture are all land-based, so we don't actually put anything out in the water. Yeah.
So
now,
a land-based.
Go ahead. We do have radio beacons. Radio beacons are also used on oil platforms to guide in the helicopters.
So a non-directional beacon. Now, as a pilot, I can attest that a non-directional beacon sure will help you fly the plane or the helicopter in the direction of the beacon. If you have to make an instrument landing that is an NDB approach, that's what we call a non-precision approach. The pucker factor is usually very high. The prayer factor is also very high. But plenty of planes have been landed on an NDB non-precision approach. Tell me about what these beacons do at airports and something about their characteristics.
Well, essentially what the NDB does is it's operating on a carrier frequency For land-based systems, that would be somewhere in the range of 190 kilohertz to 535 kilohertz. So it's broadcasting a carrier, and on that we have keyed amplitude modulation, Morse code, which is the identification code of the particular airport. So in Halifax, for example, the airport here is YHZ, and you typically see those letters on your luggage tag when you're picking up your baggage at the airport. So that's the airport identifier, and that's the identification code that the beacon would be keying. So the pilot, as he's flying into the airport, he would set his ADF set, or automatic direction finder, to that particular frequency, and the radio compass would then home in on the strongest source of the signal, which would be the NDB tower. So the radio compass is pointing at the NDB tower, and also on his headset, the pilot can hear the identification code of the airport being keyed. So he knows he's pointing at the right beacon, and he's listening to the correct identification code for that particular airport.
I want to mention something. If listeners or viewers are unfamiliar with the receiving gear in an aircraft, at least the ones that I'm familiar with, there may be others, there are actually two antennas on the aircraft associated with the NDB. They're with the ADF, the automatic direction finder. There's a long wire antenna, and this typically will stretch from somewhere above the cockpit. This is on a small plane. I'm talking about a 4-seater, 6-seater type of airplane. From a point above the cockpit back to a point on the vertical fin on the tail of the airplane. And this is the long wire antenna. And then there's also typically a loop antenna, or two loop halves or something like this, also on the tail of the aircraft. It can take different forms. I've seen this different ways. But this is the sensing antenna, the sense antenna, that determines, by comparison with the long wire, from which direction around the airplane is this signal coming. So it actually, the needle on the indicator on the aircraft instrument panel actually shows where the signal is coming from in relation to the airplane itself. So if you turn the airplane, the needle turns and always points toward the non-directional beacon. Gary, have I got that kind of right, or am I misremembering anything?
No, that's essentially how that system works. So it does point to the radio compass does point to the beacon antenna, or the strongest source of that particular carrier frequency.
Now, I've always wanted to say this to someone from Nautel. You guys would get more listeners if you'd put more interesting programming on your stations. Because I've sat in plenty of seriously, I've sat in plenty of rental general aviation aircraft, and the ADF receiver was tuned to some commercial station near the city of interest, right? So they're listening to the Cincinnati Reds baseball game on the way flying in, or the Braves game or some such. They're not usually. Of course, the problem is broadcast transmitters are usually not located at the airport. They're located somewhere else. So if you want to fly to the airport, you got to tune into the NDB. And
yeah, that's correct.
As I said, the programming kind of sucks. So you mentioned that Nautel was the first to develop a solid state directional beacon transmitter, and this was back in '69, right?
'69, yes.
Yeah.
Prior to that, they had been manufactured with vacuum tubes.
Yeah.
And our founder, Dennis Koval, he worked for a local company here in Halifax at the time. He was originally from the UK, but he emigrated to Canada. And the Transport Canada had come out with a specification for a radio beacon, and they were looking for a particular MTBF figure, or mean time between failures. And the number they were looking for was virtually impossible to do with vacuum tube technology. And at the time, Dennis thought that it would be possible to do using solid state technology that was available at the time. But the company he was working for didn't really want to take the chance on that. They didn't think it was a viable project. So what Dennis did was he developed a prototype in his basement at home, and he showed it to Transport Canada, and they were quite impressed with what they saw. And they asked him to go ahead and produce these if he was willing. And initially he was just keen to sell the design and have someone else manufacture it, but they insisted they wanted him to go ahead and produce the product for them, because he was the designer and he understood it. So that's essentially how Nautel was born. It started in Dennis's basement, and just grew from there.
Huh. Hey, it seems like I've been to a couple of airports that where I could walk up to the NDB transmitter, and these were small ones, not high powered. These were pretty small local airports, and they had a tower, not real tall. I want to say probably not more than 30 feet tall, 25, 30 feet tall, but top loaded. It's usually some kind of a coil looking thing around the top. And then the transmitter was typically, the ones I saw were bolted to the side of the tower. But I believe I did see some Nautel brand ones, but they were surprisingly small, a couple of shoe boxes in size. Am I thinking of the right thing here?
Yep, that probably would have been our ND200 model. That was a 50-watt transmitter, and it was housed in a weather-tight cabinet, so it could be mounted outdoors and bolted to the base of the antenna or very close to the antenna, along with the antenna tuning unit.
Ah, okay. So yes, there had to be a tuning box between the transmitter and the tower.
Yeah, the output impedance of the transmitters that we have produced is typically 50 ohms, and of course, with your beacon antenna, that's an electrically short antenna, so its impedance would be modeled something like some value of capacitance with a small resistance. So what we need to do is then transform that reactive impedance to resistance. So we would resonate that with a loading coil in the automatic antenna tuning unit. And this would be an automatic tuning feature in the box. So there would be loading coils in there that would automatically adjust their inductance to resonate with the capacitance of the antenna. And then we would have a matching transformer in the ATU that would transform the low resistance of the antenna up to 50 ohms to match the output impedance of the transmitter.
I didn't realize these things were automatic. I figured they'd be, the installer would set it and then forget it after that. So you made automatic ones, huh?
Yeah, due to changes in atmospheric conditions, we find that the capacitance of the antenna relative to ground can change. And so our antenna tuning units will typically compensate for a plus or minus 5% variation in the capacitance of the antenna. And initially, our older ATUs had a fixed tap matching transformer. So for example, if the resistance was 5 ohms and you tapped it for 5 ohms, if the ground resistance changed much over seasonally, for example, if you had a very dry period or a very wet period, someone may have to go back to the site and re-tap the matching transformer to give you a very good match to 50 ohms. But our newer antenna tuning units also compensate for changes in the antenna resistance or changes in the ground conductivity. So not only do they compensate for changes in the antenna capacitance, but they will also compensate for changes in the antenna resistance.
What kind of a ground system is typically installed with an NDB?
Typically, they would have just copper radials buried in a symmetrical pattern around the base of the antenna. And from our experience, we've found that typically the radials should be as long as the antenna is high. You wouldn't really want to go much shorter than that. You can always put, as much copper in the ground as you like. It's, it's always better, but then of course it gets a bit expensive. But yeah, 60 radials, 60 feet long for a 60-foot high antenna. Some customers use symmetrical T antennas, which we would probably put down a slightly larger ground mat. But it varies from site to site.
And actually, I was going to ask you about the symmetrical T antenna. We were talking about this earlier today. Some regular listeners of the show know that I have a couple of radio stations in American Samoa. And, to get there, you fly to Hawaii and then you turn left. And halfway to New Zealand, there's a little tiny piece of America called American Samoa. And they do have a good-sized airport there. And on the airport is a pretty high-power, non-directional beacon. I want to say they have a Nautel transmitter that's on the neighborhood of 10 kilowatts in power. I mean, if you're an airliner and you're still, 1,000 miles out and you want to try to pick up the NDB for American Samoa, which I think the airport identifier there, what's PPG, but I think it's actually KPPG. You want to be able to pick it up, and so it may take a 10 kilowatt transmitter. So it used to be that they had an antenna there with the NDB transmitter. The antenna, of course, was outside, out in a field, and it was a vertical run of wire, maybe two of them actually, going to a horizontal run of wire that was suspended at each end by a tall telephone pole with a crossarm on it. So you had these like two parallel T's, and you called this a symmetric T, and this has a ground system underneath it as well. Yeah.
Yes. Yeah. Yeah.
So-
Any non-directional beacon antenna, where we're transmitting in the LF/MF range, and it's ground wave at these frequencies. You do need a ground plane installed, because that's essentially the bottom half of the antenna. That's the return path for your radiated signal.
I don't know why I was thinking that only AM radio stations need a ground radial system, but of course other ones do too. Yeah.
Yeah.
But now I mentioned to you earlier today that they had taken this particular antenna down and replaced it with something else, and I'm sorry, I'm not visualizing it very well right now. A single tower, maybe that's top loaded. Why would they have done that?
For various reasons. It might have been just the age of the antenna. They might have found they needed something a bit higher. Although a symmetrical T antenna tends to be fairly efficient compared to just a single stick, but they may have put up a higher lattice tower in what I called a hot guide arrangement. So actually the tower is base insulated and live, and the top portion of the guying is also hot down to the insulators.
So I was thinking about the powers of these NDB transmitters, and we've talked about a small 50-watt one, which I guess plenty of smaller airports might have. This one in American Samoa that I believe is 10 kilowatts. What other power sizes of transmitting values do you see on NDBs?
Well, the line we have currently, our lowest power is 125 watts. We make a 250, a 500, 1 kilowatt, 2 kilowatt, and a 3 kilowatt.
Ah, okay. So nobody's got like a 50 kilowatt NDB then?
No, that's that would be much higher power than would be typically required for a non-directional beacon.
Gotcha. Well, I still think they'll get more pilot crews listening if they play some good music. All right. Hey, I want to. I guess before we get to our subject, which is differential GPS, are there any other kinds of nav aids that you want to let us in on? Something that we haven't covered, or that we maybe as broadcasters we don't know about?
The only other system that we've been working on recently, which is relatively new for us, is eLORAN. It was a transmitter we developed. Typically, up until now, there's only been one company in the U.S. manufacturing LORAN systems, and they're very large, very expensive systems. So we thought it might be time for another player to join the market, then come in with some using some new state-of-the-art devices, come up with a high-efficiency system that would use a lot less power, a much smaller footprint. And unfortunately, we had our prototype ready to go just as the funding was cut to the LORAN system in the U.S., and it looks like around the world it's starting to phase out. But there's been a resurgence in interest there, because there's been a lot of talk about a terrestrial-based backup system for GPS. And I know we have lots of satellites up there, but there's always this worry that something may happen. There may be a catastrophic failure, or there could be some type of conflict which causes some of the GPS systems to go down, some of the satellites taken out, and it would be great to have a terrestrial-based system that was under our control. So that's one possible use. Another is for timing. There's a lot of timing information derived from the GPS signal, and again, to have a terrestrial-based timing network, again, that's under our control, that's on the ground, and it's something that we can maintain easily, is also something that's being looked at rather carefully.
Gotcha. Gotcha. Huh. Well, I guess we ought to jump right into this idea of differential GPS, and I bring up GPS, and I want to get Chris Tarr to jump in here because we were talking about geocaching earlier, and in geocaching in that sport, you use GPS a lot, don't you, Chris?
Oh, absolutely. I mean, that's how the game was designed. Actually, how geocaching came about was when they got rid of, and I'm sure you'll discuss this as part of the DGPS, is they used to have the dilution of precision, which made GPSs not really very useful on the ground for handheld devices back in the 90s. And they selective availability. Once that cleared up and they changed that, GPSs became fairly accurate, and that's how geocaching got started. Is when they did that, one of the founders of basically the organization that started geocaching, he went and he planted something, wrote down the coordinates, and posted them on Usenet, and there's how geocaching got its start. So, it's amazing if you think about it, how our lives have been changed because of GPS. I mean, how many people now even look at paper maps anymore? With GPSs in cars, navigation in cars. Even your phones have GPS built in typically, and you can figure out where you're at. So, GPS has really made a difference in everyday life in ways that, we don't even think of. For example, in broadcasting, if you're running any kind of HD radio at IBOC, chances are you've got a GPS receiver to help the timing of the encoding. So everywhere you look, GPS is serving a very good purpose. But again, where DGPS is, where you'll get in a second, wasn't always that way.
Now, before I go and misspeak about selective availability, and by the way, every time I hear that selective availability, it reminds me of a girlfriend I had back in the 90s. But anyway. I thought I had heard that all this selective availability got turned off, such that now we were getting pretty accurate GPS. But apparently, that's still not the case. We're not getting as accurate a GPS signal as we could, and there's always the possibility that selective availability will be cranked way back in to where you don't have accurate or as accurate positioning. And in the aviation community, they have this. They have a satellite-based differential GPS signal. It's called Wide Area Augmentation System, or a WAAS. And I've got a GPS receiver meant for geocaching and sporting activities that has a WAAS receiver in it as well as the usual GPS receiver. And it takes more battery power, but occasionally it comes on and says, "Hey, you've got really good accuracy now, down to about 1 meter or so." So before I step in it and say something wrong, Gary, why don't you fill us in a bit on the accuracy of GPS that we really actually get to work with as civilians, and where differential GPS comes in to help that.
Mm-hmm. Okay, well, I'm certainly not an expert in GPS, but my understanding is that with today's technology and the receivers that are available on the market, GPS only, you can typically get about 10-meter accuracy with those systems. But for navigation, harbor approaches, these types of things, you need something in the order of 1 to 3 meters or better. So in order to get that, the U.S. Coast Guard developed the differential GPS system. And if you're familiar with GPS, you know that your receiver's pulling down signals from the satellite. And, the satellite's up there whizzing around in outer space, and they could be changing position slightly. Their position's being broadcast to a ground station, and the ground station knows where the satellites are, and it can send a new position to the satellite, and that information is then relayed to the GPS receivers. But due to atmospheric conditions, and depending on where you happen to be on the planet, these signals may not be as accurate as they could be. So the principle behind differential GPS is that they have a number of ground stations located across the U.S., and I believe there's about 86 ground stations. And at each ground station there is a GPS receiver. So the GPS receiver is also pulling down the signal from the satellite. But the interesting thing is the ground station is at a fixed known location. It's been surveyed. It's known precisely where it is. So it's receiving.
Gary, tell you what, we've got some pictures, and you are describing this wonderfully. But we've got these pictures to go along, and I took them, so I really want to get them shown.
Okay.
How's that for egotistical? So we're going to get Andrew, our producer, to go ahead and start showing some of these pictures. And the first one that we have, by the way, the site that you're going to see here is a site in near a little town, not even in the town, but near a town. That's not the first one, Andrew. At least that shouldn't be. A little town called Bobo, Mississippi, and it's actually referred to by the Coast Guard and other organizations as this is the Bobo, Mississippi transmitter site. And it used to be, years ago, it was one of these government facilities that had a UHF receiver and transmitter and a long wave AM transmitter, and it could receive data from Air Force One or other Strategic Air Command aircraft flying overhead, and it would relay those by long wave communications to the Strategic Air Command center back in the Rocky Mountains. And there were a bunch of these sites around the country that could do that. And that was back before we had reliable satellite communications, and they had a bunch of these sites. Well, they decommissioned these sites back around, I think around 2000 or maybe a bit earlier.
Those are the Autovon, right? Is that what
that's called? Autovon?
I think it was Autovon.
Okay. Well, here's the picture, and I'll describe a couple of these until we get Gary to describe them, in detail. The first picture here was it's a tower at Bobo, Mississippi. It's constructed like an AM tower, so there's a base insulator at the bottom. And in fact, if you go to the next picture or two, we may see some closer ups. It's a series fed AM tower, and it also is top loaded. So that means there are guy wires that go to the top, and those guy wires on their way down to the guy anchor points are broken up by an insulator. Here's the generator and the transmitter building. So one of those buildings has a diesel generator, and the other one has all this GPS and other gear in it. And the next picture that we're going to see, and I'm sorry, I'm on a 4-second delay here, so I don't always see the next picture. We should be coming up to a closer picture of the tower base. So you can see the bottom of the tower. There's the car parked in front of the generator and the other building, the transmitter building. I thought we had another one here. Maybe here it comes. Sorry, I don't have a real-time video back feed. Well, I took a lot of pictures from there, didn't I? There we go. There's the
there it is.
The tower base. Yep. All right.
So you can see the base insulator there.
And by the way, the building next to the tower, that's the antenna tuning unit. And that has quite a bit of transforming to do to go from the, I suppose, 50 ohm output of the Nautel. Now, Gary, here's where I want you to start back in. We'll go picture by picture here. And I know you haven't seen all these, Gary, so do your best. There's a couple of GPS antennas there, and they are precisely...
There's a couple of GPS antennas, precisely located. So they're pulling down the signal, and they're comparing that signal with where the base station knows where it precisely is. And it's calculating a difference or an error signal from those two. And what it's going to do is then take that error signal and transmit it out over the DGPS transmitter at the lower frequency.
And by the way, I was told that there are actually two little short towers just like that. Okay, there's one of them, and then there's another one. And each of those towers has 2 antennas on it. Actually, 3. There's a third little white antenna just a couple feet down. But the 2 big gray antennas are the precision high-performance GPS antennas. One of those little towers also had some equipment from the National Oceanic and Atmospheric Administration, otherwise known as NOAA. There was a precise temperature monitor and I'm not sure what the other monitor was for, maybe for just atmospheric pressure, barometric pressure. So the location of those 2 little towers, and there are 2 of them there, is well known. What's the brand name on that thing? Can everybody read that upside down? I'm not sure I can. But that's the underside of one of the GPS antennas. We can move on at your leisure, Andrew.
And of course, at these sites, everything's duplicated for full redundancy.
Yeah. Although they only had one Nautel transmitter.
Yes, but it's a dual transmitter.
Okay. It itself had plenty of redundancy. There you go.
Yes,
So
it has a main and a standby side. Yeah.
There's the NOAA gear right there, along with the GPS gear and a little bit of the big tower behind it.
Mm-hmm. There's the tower.
And we really do have some interior shots coming up. There's the tower. Oh, now there's an insulator in the guy wire. You see that ring? That is part of an insulator in the top guy wire, which is acting as a top hat or a loaded top section. Makes the tower look electrically longer than it really is.
Yes, just adds capacitance to the top of the antenna.
Eric Adler gives us the website. It's SCIGN or sign, maybe, scign.org. Actually, the reason the engineers were out there was for several things. They're doing regular maintenance, but also they were inspecting the guy anchor points. And they had detected some serious rusting and some things that were under the dirt that probably shouldn't have been under the dirt, which is why they had the fence taken down and they had a little backhoe and they were backhoeing into the...
Jimmy Hoffa?
There's a couple of air conditioning units on the back. They have dual redundant air conditioners on these units. By the way, these buildings are the same buildings that were in use when this was that whatever Chris said site for presidential communications. They were supposed to be EMP protected. I don't know how they actually tested that, but they were supposed to be EMP protected. Now they're no longer EMP worthy. Okay, Gary, go ahead. What are we looking at there with the Nautel transmitter and the rack?
Yep, this is the Nautel transmitter on the right. That's our 3 kilowatt DGPS transmitter, and you can see in the front of the unit there. You can see the power modules that are plugged in the front. So we have a side A and a side B. So if there's a problem with side A, the transmitter would automatically change over and operate on the B side. And at the top of the cabinet is the control panel for full local control of the transmitter. And also, of course, it can be remotely controlled. And the rack to the left would be a lot of the reference station equipment, the communications gear to the central control. I see a modem there, data modem.
And we can go forward, Andrew. We can go forward another picture or two. There's a close-up of the Ethernet patch bay and switches there.
Yeah,
and
there's the Ethernet patch panel.
Gary, one of the things that we harp on this show is just how much Ethernet IP there is with broadcasters nowadays. And most engineers are getting to know this stuff. But if you haven't, I got to tell you, you got to start finding out about Ethernet IP because it is everywhere, and here it is at this transmitter site for DGPS.
Yeah, no, it's the way everyone's going now. We're not using dial-up modems or lease line modems. It all seems to be IP now.
I got to say, except this site. This site is out in Bobo, Mississippi. You just can't get strong Ethernet internet in Bobo, Mississippi. So you can see they actually had the left-hand thing. There is a Zoom modem.
They do have a modem there.
Some kind of a lease line thing. The other
they dial up AOL, get online, set out the coordinates, and hang up.
Well, that is the backup upon backup.
There's the front panel of the transmitter. So it has an analog meter, but it also has an LCD display we call the GUI, graphical user interface, and it has a menu system with selection buttons. It has a little system diagram there, block diagram of the transmitter's key functional blocks, and if a problem occurs in one of those blocks, a little red LED lights up. And this information is also transmitted remotely back to the central command station.
I think the next picture or two might depict that a little bit better. The front panel. There's a little wider shot of the front panel within the next picture or two, Andrew. Now, Gary, help me understand this Nautel transmitter. What modulation? What is it transmitting?
It's transmitting what is known as MSK. That's minimum shift keying.
Okay.
So that's a special case of continuous phase frequency shift keying.
Whoa!
So they're essentially sending out binary ones and zeros, but binary data consists of sharp data transitions. So when we're switching like that, we don't want to occupy too much spectrum. So we can filter that, or we can use a different type of modulation technique called MSK.
And the receivers, the DGPS receivers that presumably are typically on boats on the Mississippi River and in the Gulf of Mexico and our Pacific and Atlantic Oceans, these receivers, are they able to adapt to different modulation techniques that are being used?
Well, they would be receiving both GPS, and if it is truly a DGPS receiver, it would also be receiving the MSK broadcasts from the ground-based beacons.
Okay, all right.
So
is this a large amount of data or just a very small correction factor that's being transmitted?
Relatively small correction factor. They're regular broadcasts. I don't know what volume the data is, but typically the transmission speed is 100 baud or 200 baud, so it's not a high transmission speed.
Gotcha. I got a couple close-up pictures of these modems. One of them is an Adtran DSU IV or 4 ESP, so that's a full-time loop, and the other one is a Zoom 56K dual mode modem, which I kind of had to snicker. But you go outside, you look where you are in Bobo, Mississippi, and there's just not much out there. Yeah. By the way, these buildings have been refurbished from their original uses with a contract over the last few years, and I think there may be some placards that we'll see. But the buildings that you're looking at, I don't think these are the actual original ones that were on the site. They probably swapped them around from site to site, but these are all shippable containers, and they are very well outfitted under contract to do this purpose. And they were outfitted, with all the things I guess that OSHA requires, emergency eye wash. I may have a picture later of I think you'd call it a Jesus stick. They had a hook, a shepherd's hook for getting somebody off the high voltage should they fall into it. There it is. Actually, this may have been in the no, this is in the main building. Some things for safety. If you're out there in Bobo, Mississippi, you don't go alone, and you want to make sure that there's things there to help you get your friend off the high voltage.
Yeah, no, that's a good idea.
I think there's also some pictures as we move along. Here's also some pictures of the. I should look and see what's next here on my own list. Sorry, this isn't all that well.
Yeah, those are a lot. They've got some
inline
surge suppressors for the various antennas that they have on site, and they have those all connected to a nice wide copper strip for good grounding. Typically, we would like to see a nice wide copper strip then going down to the station reference ground. I see they've got some fairly heavy copper cables coming away from that, but typically we'd like to see one solid connection to the station reference ground.
I think they actually have. There's some that are going up to other places, but I believe they actually did do that. These buildings were certainly designed with that in mind. I wanted to show this picture of the ground reference bar and the various Polyphasers, a popular brand, the various surge suppression boxes that are there that you can see the data lines go through, and the RF lines. Most of those would be from the GPS antennas outside that they go through. And I'm not sure where or if the Nautel transmitter's output goes through any of these on the block. I can't tell by this picture, and I don't remember particularly. But what I'm getting at is, broadcast engineers, this is a good way to do it. There may be slightly better ways. There may be better techniques as far as just actually handling it, but they fit a whole lot of grounding on this block. And I'd love to see more broadcasters, including myself, go to this length to get your stuff grounded. It sure is important and will sure help you out in the long run. One of the places I learned about protection from lightning and surges and proper grounding is from a Nautel manual. Gary, what could you tell me about what Nautel has learned about this and how Nautel teaches its customers how to live a long life or have their transmitter live a long life?
Yeah, well, over the years, we've learned a lot about lightning protection, and also grounding techniques, proper grounding techniques for radio stations, NDB stations. So we offer training courses for customers along with the equipment training. We throw in some antenna theory. We also throw in some information about proper site setup and grounding and lightning protection.
Well, in the back of your transmitter manuals, at least the AM ones that I've seen, the section about protecting from lightning is just terrific. And every engineer, whether or not you're going to buy a Nautel transmitter, you need to read this section. And I believe it's available online from the Nautel website. Just some great ideas. And so many transmitter sites are built not realizing this, and in such a way that, let's see, the tower is over here, and the coax comes in the building, and then there's the transmitter, and then there's the AC power leaving the building on the other side. And what we have here is a situation where your $30,000 transmitter is just a big fuse.
Mm-hmm. Well, Kirk, speaking of Nautel, this might be a good, we need to get Jeff Welton on the show to do his presentation on grounding. For transmitter sites. He tends to make the circuit and does a really, really good job with that.
I didn't know he gave that presentation. I know Jeff, and we ought to get him on the show to give us that presentation. That'd be awesome.
Yeah, definitely.
So I was going to type this to Andrew separately, but hey, Andrew, if you'll forward a little bit, there's some pictures of the generator building. Just look for pictures that look like they came straight out of 1962, and and you'll see they didn't. There's some controls. Oh, there's a big stop button for, I guess, for the there we go. There's the generator. This is so squeezed in here. I don't know how you'd work on this generator. You got to weigh 110 pounds soaking wet to get yourself into this room and work on stuff. And by the way, the fuel tanks are in this room. If you go back there you go. Yeah, the fuel tanks are in the back of the room on the left. I think there's 2 tanks, because where else are you going to put them if it's all EMP protected?
Yeah. Wow.
So I think that generator, I'm sure, dates from the 60s. Real reliable. Runs great. Let's see, Andrew. There's a paper there that we probably ought to skip over. It's got some phone numbers on it for the site. I don't want people calling the site. What else was next here? Let's see. Sorry.
There's some RF gasketing on the doors.
Yeah, I wanted to point this out. Gary, you probably know something about this. Why are the doors designed this way?
It's just to give you a good seal for RF, anything coming in or anything leaking out. So they've put gasketing all around the doors so that when they close them and seal them up, they've got a good electrical connection between the door itself and the frame of the cabinet.
And we're not talking about the bank locks, the bank bolts there. We're talking about the little half-round silver finger stock that is along the door.
Yeah, that runs all around the edge of the door. That gives you a pretty good RF seal there.
Gotcha. And there's a close-up of that. Oh, and there's an upcoming picture. There is a picture of the fence.
Yes, and they've got the gate grounded to the fence, so it's a good idea to have that well grounded. You don't want your gate to become alive on you and start to pick up energy from the antenna.
And I've seen so many cell sites where grounding like this was done very well. Chris, this looks CAD welded to me. Does that look like CAD welding, or is it just screwed on and painted over?
No, I think it's probably, I can't see the picture, but I looked at it earlier today, and that looked like a CAD weld to me.
You know what? I got the next picture kind of shows us from the side. Yeah, it is CAD welded. Chris, have you ever done any or had CAD welding done?
Oh yeah.
Really? Tell me a little bit.
I do that. You do that a lot with just for exactly what that shows, or like for towers, things like that, when you're doing those grounding straps.
All right, I'm a little ignorant to the process, and I know it's a good thing to do because it's not going to come apart. It's not going to rust, at least from between the connectors. How do you get this done?
That's a very good question. I'm not a welder.
Oh, okay. Gary, do you know?
No, I'm not a welder either.
Wow.
Sorry.
I've heard you can buy kits to get this done. I'm sure people in the chat room know about this. We got to get I got to get a tower guy on our show and have him talk about CAD welding, because I think it's fascinating. It makes this incredibly permanent bond, this oneness between the cable and whatever you're connecting it to, a piece of tower or a ground rod going in the ground. And it's, this connection may have to carry a high amperage of electricity if lightning strikes. Or in this case, it's just to keep everything at the same RF potential. So the wire's relatively short, just long enough to let the gate swing open and closed. This kind of
that's the problem if you just do your standard kind of welding and tack welding, is that when you get that high voltage current going through there, it just blows it out.
Yeah. If you just have and so many people will, like me in the past, dummy, or not having a better way to do it. We've just taken we have a grounding kit on a coax, right? And so it terminates in a lug. And so what do? Well, you scrape a little paint and maybe some galvanization off the tower, and then you put a hose clamp on it and clamp it down as tight as you can, and then you kind of wrap it up with some tape. And is that
or
really
you get out some MAP gas and a brazing rod or something, or some silver solder, and you can do that too.
Yeah, I've done that. Yeah. Well, the last picture I want to show shows this placard, Nationwide DGPS Electronic Equipment Shelter. I don't know, is that? Yeah, there we go. Gary, have you seen these before?
No, actually, I haven't. This is the first time I've seen these detailed photos of an actual DGPS site. So.
Well, this is obviously the placard they put on at the Raytheon Technical Services Company, the government contractor that refurbished these and rebuilt the shelters into what they are now. So I guess somebody could look up these contract numbers and go get some details. They're probably available online. So anyway, we've seen the pictures now of the site. Now, Gary, maybe there's some details that we didn't get to talk about. You started to say, or you mentioned that the GPS receivers are located at surveyed known points, so we physically know where they are supposed to be. And then the receivers read what the satellites say, where the satellites say they're at. Mm-hmm. And there's going to be a difference between these two numbers, right?
Yep, there's going to be a difference there for various reasons, atmospheric conditions or what have you. And so what's happening then is the reference stations are then broadcasting the corrected positions out to the handheld receivers. So in conjunction with the information that's being pulled down from the satellite, you also have the local correction codes being transmitted, and then your DGPS receiver can go ahead and calculate a much more accurate position for you. So it can get you somewhere in the range of 1 to 3 meters. And if you're using a much higher accuracy receiver, you can even get down to 30 centimeters.
If you're docking a barge that weighs many, many, many tons, this is important.
It's very important. You don't want to overshoot the wharf.
Especially to the people who own the wharf. No, don't hit too hard. No, you're here, really.
Yeah.
Wow.
So the system was initially developed for coastal navigation, marine navigation, but of course it's widely used now, throughout the country by just about anyone that can purchase a handheld DGPS receiver.
Yeah, okay. Now this DGPS we're talking about here, this signal is transmitted over a long wave, a lower frequency wave, whereas the other one that I talked about, the WAS, is satellite based, and that's must be a much higher frequency because the antenna is a little patch, not much different than the GPS patch. And I guess Nautel's not involved in the WAS technology. That's a satellite in the sky.
Yeah, no, we're not involved in the WAS. And I understand you can also download the correction codes over the internet as well. So some receivers do what they call post-processing of the data. So you would download it, the information from the internet, and then the receiver would churn away, do some calculations, and come up with a very precise location for you.
When these sites are being installed, or as they go along and there's maintenance to be done, what kind of trouble would befall a transmitter that's sending out this kind of data 24/7? Anything that a broadcast engineer wouldn't think of? Anything weird?
I think typically the problems you have with these types of systems would be either lightning related, damage due to lightning, and also I know from time to time we've had calls on our transmitter that have turned out to be communications issues between the command center and the transmitter site itself.
Hey, the transmitter's not answering the phone. Well, phone line's down. You know what, Gary, I don't mean to pause you here, but we're going to have some final thoughts in a couple of minutes. I neglected halfway through the show to talk about our sponsor, and they do pay money to make the show possible, so I really appreciate that. And our sponsor on this episode of This Week in Radio Tech is my employer, one of the divisions of my employer, and that's Axia. Axia was the first company to make these consoles that are totally IP audio. This is audio over Ethernet, but it's not CobraNet, it's not EtherSound, it's LiveWire. And LiveWire is a little bit different from those other technologies in that it's extremely low latency, which is absolutely required to talk in a mic and listen to yourself in your earphones or headphones. You've got to have very low latency, like under 3 milliseconds. And it's completely routable. It's routable by a layer 3 switch, and so that's and LiveWire is really nothing more than a collection and really smart usage of existing protocols like RTP, real-time protocol, and UDP, user datagram protocol, and QoS, quality of service tags. And so we just do a lot of smart things to make LiveWire fly around a network and do it really fast and completely routable. And that's what Andrew Zarian's using at his GFQ network. I want to show you, though, this is a great catalog. If you don't have this, I sure would encourage you to pick one up. You can do so at the website, telosalliance.com. This is your Christmas wish book, engineers, fellow men, fellow women engineers. And I'll turn to a page here. I've turned in the catalog to a page here with some beautiful Axia accessories. Now, we've talked about the audio consoles before, but there's a lot of accessories, things that you might want to make your station just a little better, operate more smoothly. We have these microphone controls. I have the page open to that. This is for your talent. They can turn their own mic on and off. They can monitor different channels. They can mute their mic temporarily to cough. And they also can push a button to let them speak quietly with the board operator. Hey, I have to go to the bathroom. Can we go to a commercial? That kind of thing. Very handy in certain cases. Also, there's a whole section of IP-based intercoms. These are really cool for a station that has intercom, or maybe you've never tried intercom before. You can get a lot done by being able to just get a quick message to the program director or the producer or the news director or the guy in the traffic copter. These intercoms will absolutely help you get it done, and they plug into the same Ethernet switches that everything else in Axia plugs into. Very cool intercoms. There's even a soft intercom that runs on Windows and lets you have an intercom station at your PC with the rest of the radio station. One more thing I'll show here, and that is Pathfinder. Pathfinder is not required for Axia to work, but you can do some awesome things with it, including you can make these virtual mixer panels. So if you need a few more mixers around the newsroom or production rooms, or to do some dubbing, there you go. You got these mixer panels that just come as part of Pathfinder Pro. Check it out on the web, telosalliance.com. You can sign up to get your catalog. You can download it, and we'll mail you one. No matter where in the world you are, we'll figure out a way to get one to you. All right? I appreciate Telos very much for sponsoring This Week in Radio Tech. Thanks for their generosity and their caring about the broadcast industry to get this done.
Hey, Kirk, before you move on,
yes, sir.
I have a bunch of those catalogs from all the Axia equipment that we've gotten,
yeah.
And almost all of them are gone. Everybody that comes into the studio takes one to go.
Okay. Good. Our plan to take over the world is in force. That's great. I appreciate that, Andrew. Make sure that the directors of engineering of all the big New York stations get them, okay?
Will do.
Okay. All right, Gary, we've blown through an hour here. And I'm sure there's some aspects of differential GPS we haven't covered. Well, what comes to mind, if anything, that we haven't talked about yet?
We haven't really talked too much about, I guess, the availability of the system. The system is designed to maintain an availability level of about 99.7%. So the Coast Guard have realized it's very important. Once you start providing that service, it has to be there once people start depending on it. So it's designed to be as reliable as possible.
I did notice that if you do a little Googling, you can find a map of the current setup of these DGPS transmission sites. And most parts of the Gulf Coast, the East Coast and West Coast and the Mississippi River and the Great Lakes and the seaways, most of them are covered by 2 transmitter sites. There are a few stretches where only 1 transmitter site's covered. And this stretch of the Mississippi around this Bobo, Mississippi site is one place, in fact, where there is some coverage that is, if that transmitter site goes down, well, there's boats that don't get their differential GPS.
Mm-hmm. Yeah, no, there's usually a bit of coverage. Sometimes there's an overlap in coverage, and that gives the receiver an opportunity to receive from more than one transmitting site.
Gotcha. Now, this is there any concern with the notion of duty cycle with the transmitter that's sending this data out?
Nope, the transmitter is designed to operate 24/7. Actually, the transmitter we use for DGPS is a modified version of our non-directional radio beacon, so the thing can run 24/7 continuously unattended without any trouble at full power.
Ah, okay. And once again, if you could spend just another moment on this narrow frequency shift or phase shift keyed modulation, can you describe that again, or maybe in a bit more depth? I'm not sure I've got that really worked out in my head.
Yeah, the MSK is as minimum shift keying. Again, I'm certainly not an expert on the that whole modulation technique, but it's a continuous phase technique. So where we have a continuous phase transition with the data, it doesn't occupy a large amount of bandwidth. So we're essentially have a carrier frequency, and in this particular case, the radio beacons are running in the frequency range of 285 kilohertz to 325 kilohertz. So interestingly enough, that's inside the non-directional radio beacon band, but that particular frequency range is set aside for marine navigation, and that's why it was chosen for transmission of the DGPS correction codes.
You know, there is an entry in Wikipedia about minimum shift keying, and boy, it might take a while to wrap your brain around this. Hey, Chris, listen up. It says here, similar to OQPSK. I didn't know there was an OQPSK. I guess that's orthogonal quadrature phase shift keying. MSK is encoded with bits alternating between quadrature components, with the Q component delayed by half the symbol period, just as I was thinking. However, instead of square pulses, as in OQPSK, MSK encodes each bit as a half sinusoid. Very smart. And this results in a constant modulus signal, which reduces problems caused by nonlinear distortion. So you end up getting a constellation, looks like, of 4 different possible bytes of data. You have a 0, 0, 0, a 0, 1, a 1, 1, and a 1, 0. So, okay. If you want to check it on Wikipedia, there's minimum shift keying right there. Gary, any reason that you know of why MSK was chosen? You mentioned because of the narrow bandwidth available.
Yeah, narrow bandwidth, and also it doesn't tend to interfere with the carrier frequency that you're operating on. So if the beacon is geared to 285 kilohertz, it can still be received by a standard beacon receiver. So if it's being used by ship for marine navigation, that ship can still receive it as a navigational aid as well.
Ah, okay. Gotcha. Well, I don't know what else there is to be said. This is technology that, we depend on, whether we know it or not. We're consumers of the goods that are brought to us by ship up and down the Mississippi River, the Great Lakes, perhaps a river or two out west for a little ways anyway, and the Atlantic and Pacific Oceans and the Gulf of Mexico. So this stuff is important, and it keeps things hopefully from bumping into each other. Like, I hope they use it to keep barges from running into bridges that cross, spans like over the Gulf and places like that. We certainly have had a few of those in the last few years, but that may have been before we had wide deployment of DGPS. Gary, thank you for being with us. I appreciate it very much, your explanations and taking the time out for us.
Oh, thank you very much for having me on. I enjoyed it.
Chris Tarr, wake up, buddy.
I'm here.
All right. You got any last questions for Gary or comments or words of wisdom?
No, I actually, we were just, Andrew and I were talking in the background of the chat. It was a very interesting stuff. I didn't really even know that those existed. So I learned something new today.
Yeah, they're in out of the way places like freaking Bobo, Mississippi. I mean,
as you guys like to say it down south, Bobo, Mississippi.
Yeah, that's right, Bobo. There's 4 syllables in Bobo, Mississippi.
Bobo.
And I would imagine most of these transmitter sites are off in, let's say, less desirable land areas. That used to be a hazardous waste dump. Now it's a DGPS facility.
Yeah, just wherever they could find a spot to put it. Yeah.
Exactly. Somewhere maybe close to the water. All right, guys, thanks so much. Thanks to Telos and Axia for sponsoring the show. Gary Galbraith from Nautel. Gary, if folks want to reach you or reach Nautel, where would they look on the web?
The best spot for our navigational side would be www.nautelnav.com. That's nautelnav.com.
Oh, good. And that's where you have all the listings for transmitters for weather radio, Navtex, NDB, DGPS, eLORAN, and even sonar. If you're looking for that special gift for that special someone, a sonar amplifier. Chris, hope you enjoyed your day off. You get another one tomorrow?
I have a few of them, yes.
Oh, good. All right. Well, have a good time off. And guys, Andrew, I need you in here. Guy, are we going to have a show next week or not? I heard you saying this was our last show this year.
Oh, I think you guys are on because you said you want to be on next week, right?
Well, we can arrange it or not. I'd kind of like to be on if we can do it. So we may have to play it by ear.
Then you guys are on.
We'll see who's available, okay?
I'll be here.
I do want to mention that coming up in an upcoming show, we have Mike Durow from Durow Electronics, inventor of the Durow loudness meter and the discriminate audio processor, the DAP. So I'm really excited to have Mike on the show. He's on holiday and he's in Wisconsin, Chris. He's at his Wisconsin home.
Oh, no kidding. I knew he traveled up here quite a bit.
Yeah. Well, that's where he is, and hopefully he'll be doing the show with us from there. So, guys, thanks for joining us, and we'll see you next week on This Week in Radio Tech. Bye-bye, everybody.
That's all the bandwidth we can pilfer this week. Another tort is propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you like today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.